This is section 6.6, part 2. We are solving equations. We're solving a quadratic. The first thing we have to do is to get 0 on one side. We have a 0. Now we need to factor each side completely. So I need to look at this and think about how I'm going to get it factored. Do I have a GCF? No, there's nothing in common here and here. So that gets us to here. Do we have 4 terms? No. 2 terms? No. 3 terms? Yes. So we check. Do you have perfect squares on the ends? That's a perfect square, but 2 is not a perfect square. Okay, so that sends us to the 6.2 method. Okay, that's the method where you look for 2 numbers that multiply to a 2 and add to a negative 3. List the things that multiply to 2, 1 and 2, and that's it. All right, that multiplies to a positive 2, they add to a positive 3. I want to make them both negative, and then that will add to a negative 3 and multiply to a positive 2. So this factors as y minus 1 times y minus 2 equal to 0. And now we're at the same step we were here. Take each of these and set it equal to 0. Because if these are multiplied together and we get 0 as an answer, the only way that can happen is if at least one of them is 0. I expect to have 2 answers. I need to move this over here by adding 1 to both sides, which gives me y equal to 1. And then here, add 2 to both sides, and we get y equals 2. Okay, so let's try this one. My z squared is positive. If you recall from 6.3, I think, or 6.2, we said that it's always easier to factor if your first number is positive. So I'm going to look at that whenever I go to create a 0. I want a 0, so I need to move this over on this side, and I do that by adding 2 to both sides. And that will give me z squared plus 3z plus 2 equal to 0. Okay, so let's look at our factoring guide. Again, do we have a GCF? No, there's nothing in common here and here. In fact, this is very similar to this problem, isn't it? Okay, the only difference is here this is a plus, here this is a minus. Okay, so we do not have a perfect square on the end. So we're looking for 2 numbers that multiply to a 2 and add to a positive 3. And this time, positive 1 and positive 2 are going to work. So this one factors as z plus 1, z plus 2 equal to 0. Now that it's factored, set each of these equal to 0. Okay, let's subtract 1 from each side, and we got z equals negative 1, and subtract 2 from each side to get z equals negative 2. So we've got 2 answers. Technically, they don't matter what order they go in. They just should be put in a brace, and I forgot to do that on this one over here. Okay, so let's look at this one. I need a 0. Let me draw a line here to keep them separate. Okay, I need a 0. The easiest way to get a 0 would be to subtract t squared from both sides. But we really want the number in front of t squared to be a positive number. So it's actually going to be easier if you take both of these and move them over to here. And I would do that by subtracting 2t from both sides and also subtracting 15 from both sides. So that would give me t squared minus 2t minus 15 equal to 0. okay? Now I need to get this factored. I do not have a GCF. 15 is not a perfect square, so I'm looking for two numbers that multiply to a negative 15, that add to a negative 2. Things that multiply to 15 would be 1 and 15, 2 doesn't go, 3 and 5, and that's it. I need them to multiply to a negative number, so one of these needs to be negative. And if I think about adding a positive and a negative, I can get a 2 out of this by making the 5 a negative. So this will factor as t minus 5, t plus 3, equal to 0. Set each of these equal to 0. Subtract 5 from each side here, and you get t equals negative 5. Subtract 3 here, and you get t equals negative 3. So your two answers are negative 5 and negative 3.